blocks of matter and radiant matter, which form from stars, planets to living beings, which are made up of further divided into quarks and leptons. Then the first generation is up and down quarks, along with electron and electrons. We have charmed and fringe quarks with neon and neon neutrinos. In the third generation, we have top and bottom quarks with tau and strong forces which bind quarks together. Particles. The elementary particles known as various having neutrons, hydrogen, they fall under the common head, half electron state. There is lepton, they fall under the bottom, at the Large Hadron Collider, what we see are not the particles. These are basically the energy deposits that the particles present in the universe, they interact with the field, and as they interact, they gain mass. From the number of events with along the wire, if the photon came from some random experiment, then this blue light would have been a smooth puff of ice over here. Means the scientists understood that something has happened over here. Something different has happened. That is what the Higgs boson. What amount the dark already exists? So the amount is the 40% is the visible matter and the 86% is dark matter. We can overall say that dark matter is basically a thing which can grab the universe together or bind the universe together, and the energy thing, we can say that it pushes the galaxies out. Symmetry, that is a property, we can see that in quantum model there are in supersymmetric theory we came to know that combining the information, go deeper into it, mystery, so that particle physics is not a complete chapter of science. It is an ongoing journey where every discovery reveals even deeper. Topic is diffraction patterns and Fourier transform. Why do stars in the picture taken by James Webb Space Telescope have spikes on them? The telescope images often show structured patterns, shapes, or the image not only contains information about the object but also contains the information about the aperture. This diffraction, named after the German physicist Joseph von Fraunhofer, offers when light waves diffract after passing through a single shows the patterns are not random. The particular frequency of the sine wave is present in the given signal, then the product is positive. Otherwise, the product can be represented by a combination of different sine waves. The proportion of the peak in that signal, treating them separately, we use the order consider input signal in the time domain. So, we corresponding frequency every point acts as a source of waves and their interference creates a diffraction pattern, which we observe on the screen is actually the Fourier transform of the aperture libraries, which is normally manipulated, and then we define a function where we give the aperture dimension, the Fourier transform that we just obtained, but we are interested in the intensity to it. So equal to 1, we get the single slit diffraction pattern, and for n equal to 2, we get the double slit diffraction. The main thing about this is just by knowing the dimensions of the aperture and the Fourier transform, we are able to compute what light does in real life. As if the world is present the topic, the future of photovoltaic semiconductors and the increasing energy crisis and the environmental issues, it is very important for us to shift to the renewable energy. Solar energy is the most abundant, and since 2010 it's the most cheapest one. The material whose conductivity lies between the conductor and the insulator. We can control the electron flow, and by controlling this we can make some device like diode, transistor, and many. So first at 1839, Becquerel discovered the photovoltaic effect, which is the working principle of solar construction of solar cells. The solar cell work on the photovoltaic on a solar panel. There is a charge controller, which is the inverter, which transforms the DC current. MOSFET works as a very good standard silicon. We have shifted to peroxide instead of phosphate. Their uniform lab in Celsius and makes in case of polycrystalline panels. Makes semiconductor materials. Gallium nitride is used in high frequency and low to medium power applications. Advantages and limitations of solar. This slide shows general scientific process. One of the major examples is the photoelectric method. Another major issue was black body radiating with infinite energy at high frequency. And this radiation and matter exhibit wave-like and particle-like properties depending on how they are observed. Now that light behaves as a wave, E being lesser than V0, V0. So it suggests that there is quantum tunneling. Reflected ray I plotted the transmission efficient coefficients that I got from this simulation. From analytical plotting by using this expression. Means the error of this program is around 0.0 conductor tunneling and like superconductor 200 plus which emits alpha particles of around 8.78 MeV. So it is not possible to explain it by classical mechanics because the potential value that we have around here is around 25 MeV, but the alpha particle that is emitted is from around 4 to 9 MeV. And the energy between these two potential waves is basically the amount of energy that is required to bring the ammonia structure in a linear structure. All of these use atom tunneling these days, so it's a very common and positive research realm in electronics and semiconductor field. Superconductors, they barely face any resistance and which results to supercurrent and the concept of superconductivity. With sensors, so and quantum computing again losses and junction for superconductivity included, etc.